Hello everyone, welcome to an algebra video tutorial learning about geometric sequences and exponential functions. In this video, we're going to learn how to find the common ratio so that we can find the next term in a geometric sequence. So here we go. We've got a sequence here. I chose one with some fractions because that'll make it kind of fun. In my sequence, the first term, A1 is 18. The next term is 13 and a half. The next term is 10 and an eighth. The next term, the fourth term, is 7 and 19/32. And I want to find out, well, what is the fifth term of this sequence? It's unknown. And again, with geometric sequences, I'm trying to find out what's that pattern that I'm multiplying by to get from one term to the next. So if you're going to find the next term in a geometric sequence, you need to find out, well, what is the common ratio? Now there's a couple ways you could find it. We talked about taking any two terms and dividing them, and that gives you the common ratio. So I'm going to go ahead and take these first two terms, 13 and a half and 18, and if I divide them, 13 and a half divided by 18, that's going to give me the common ratio. Now I've got a complex fraction here. I don't like that. I want a whole number on top and a whole number on the bottom. So I'm going to multiply the top and bottom by 2. 13 and a half times 2 will give me 27. 18 times 2 will give me 36. And now I've got something that I can actually work on simplifying. I know that 9 is a factor of 27 and 36. I'm going to divide the top by 9 and the bottom by 9. And I can reduce it into simplest terms, and it becomes 3/4. 3/4 is the same as 27/36, which is the same as 13 and a half over 18. These are all three the same fractions. I just wanted to get to the simplest fraction. So there we go. That's one way of finding it. I took these two terms, 13 and a half and 18, divided them, and found out that the common ratio is 3/4. Well, let's check it. I'm not entirely convinced, so I'm going to pick another two terms. I'm going to pick the next two and divide those. So I'm going to do 10 and 8th down here. I'm going to divide that by 13 and a half, the one before that. If they're both the same, I'm going to feel pretty good about my common ratio here. So let's change them both into improper fractions. This one turns into 81 over 8 divided by 27 over 2. If you need a review on dividing fractions and doing all this stuff, definitely check out one of my earlier videos back in the real number unit. And to divide fractions, we change them into multiplication with the inverse. So times 2 over 27. Now there's some things I see I can simplify right off the bat. 2 divided by 8, it doesn't matter the orders. I'm going to eventually have a 2 and an 8 on the top. I can divide those ahead of time, divide out the common factor of 2 to turn it into 1/4. Same thing with the 81 and 27. They both have a common factor of 9. So I'm going to go ahead and divide that 9 out, leaving 9 over 3. So 9 times 1, 4 times 3 is 12. I actually could have reduced it down even further, because 9 and 12 both have a factor of 3. So I'm going to divide out that common factor of 3, and I still get down to 3/4. So I'm feeling pretty good. I tested two terms out. My common ratio is 3/4. So it looks like the pattern is to multiply by 3/4 every time. So to get the next term then, I'm just going to multiply by 3/4. So let's do that. Let's take my 7 and 19/32. And we're going to multiply that by 3/4. Told you there was a lot of fractions here to get my next term in the sequence. All right, I'm going to change this one into an improper fraction. 32 times 7 is going to be, let's see here, 32 times 7 is 224 plus the 19. And so we've got 243 30 seconds. And I'm going to multiply that by 3/4. So there we go. We just changed the first mixed number into improper fraction. Now to multiply, we multiply across the top and multiply across the bottom. So 243 times 3 is going to be 729. 32 times 4 is going to be 128. And there we go. My unknown term, the next term, the fifth term in the sequence, is going to be 729 over 128. If I reduced, or if I turn that into a mixed number, it's going to be 5, because 128 goes in 5 times, with a remainder of 89 128. All right, so that's one way to go about doing it. We found the common ratios, we double checked it, we did it a couple of times, and then we actually did the math to find the next term in the sequence. Now I want to show you another way that's kind of cool on this, is if I go ahead, if you see a bunch of fractions in a geometric sequence, I would go ahead and turn them into a mixed number, or turn them into an improper fraction ahead of time. So I'm going to write 18 as 18 over 1. I'm going to write 13 and a half as 27 over 2. I'm going to write 10 and an eighth. I'm going to turn that into an improper fraction as well, so that's 81 over 8. 7 and 19/32, we already turned that one into improper fraction here, so that's 243 over 32. Now here you can sometimes see the pattern a little bit better. On a fraction, remember we just multiply the numerators and multiply the denominators. So it's like 1 times 2 got me there. 2 times 4. There's a 2 times 4. Let's see what patterns we have here. 18, that doesn't multiply, but 27 times 3 turns into 81. 81 times 3 turns into 243. So what's going on here? The 18, we actually multiplied that by 1.5. And so you might say, well, this doesn't look right, 1.5 and 2. But 1.5 and 2, if I multiply the top by 1.5 and the bottom by 2, that's the same ratio as the 3 to 4 over here, and the 3 to 4 over there. So it is a common ratio. If I multiply the top and bottom by 2, it also turns into 3/4. So sometimes if you write it all as improper fractions, then you can just focus just on the change in the numerator and the change in the denominator, and you can see the pattern of what the common ratio should be that way as well. All right, there we go. We did a great example looking at a lot of fractions, but the idea being a geometric sequence follows a pattern of multiplying by a certain number repeatedly over and over. And once we find that common ratio, that number being multiplied, we can find as many terms as we want to.